Hi, hello everyone. So last time we left off with our depth testing, and this time I promised that we're going to do instance rendering. So what is the instance rendering? So here, for example, we had two pipelines to create two objects, but with instance rendering you can have one pipeline for multiple objects which are kind of the same, right? You just have like this instance data that you change per instance. So for example, you might use it in a game if you have a lot of trees and then you just want to change transformations of the trees. For example, you might want one tree bigger, you want move the other trees to left, to the right, all over the place, right? Or you want to rotate them, or for example, if you have an asteroids field, right? You don't have to create like you don't have to create basically what I'm saying is asteroid pipeline per asteroid. You actually create a one pipeline and then you use instance rendering to create many objects. So how would it look like? So basically what we're going to have is one pipeline, and then we're going to fill this screen with hundreds of cubes. So to achieve that, actually we need to identify which data will be our instance data. And for this video, I thought that a good candidate is probably transformations. So we're going to have same looking cubes, but we're just going to have them all over the place. And you can, in this video, I'm just going to do translation, but you can play with scaling and rotation as well. So the same thing applies. Actually, so now would be probably a good time to get. So first, let's discuss how it will look like. So for example, here we have a cube, but I'm just going to use triangle as usual because it's simple primitive. So let's say that we have a triangle with vertices 1, 0, 2, and let's say that we want the second one, which is kind of same. It's just translated, right? It's translated to the right. Maybe it's rotated a bit. Maybe it's scaled a bit. Let's just pretend that these are the same. So with instance rendering, you kind of have an array, and let's call this, in our case, it will be transformations. So we're just going to have an array of transformations, and this part of the array, right, 0, is going to represent this. This one is going to represent this one, and this 2 might be represent this one, and then up to n, right, to some n, and let's say this triangle is n. So that's how it's going to look like. So for that, we can just modify our transforms array. So I'm just going to call it transforms because it's an array. And then in shader, so we're looking at our unlit material shader. So I'm just going to say 100 here. And you need to specify, it cannot be dynamic, right? Because of the memory layouts and stuff. So you just specify that it's going to be, that our maximum number of instances is going to be 100. And how do we get that instance here? Well, we just use built-in instance index, and I'm going to call it IID for instance ID, and then we just pass it here. So back to our triangles, right? You can see we had 0, 1, 2, and then instance 2, 0, 1, 2, right? And here it's 0, 1, 2 as well. So what does that mean? That means that for the first instance, we're going to get vertex IDs 0, 1, 2, and our instance ID is going to be 0, 0, 0, right? For the second instance, right, of the triangle, so the vertex is the same, but we get 1, 1, 1. So you can already guess the next instance, right? 1, 0, 2, and then 2, 2, 2, etc. If you were rendering quad, then you might have here 4, 2, 0 or something like that, because right, you're actually connecting here triangles. So you're going to have 1, 0, 2, blah blah blah. Anyway, 4, 5, 6. I don't remember anymore, but that's it. So, and here I'm just going to have to say here transforms. All right. So the first part is solved, kind of. So the next part is actually we need to modify our buffer so that it can hold 100 objects. So let's do just that. Let's go to our uniform buffer, and I can probably expand this a bit. So here I'm just going to say data or length. So the length being the byte size length of our object. And for that we can just say if type of data length is a number, then we're going to do this, and then else we're going to create it as usual, and we're going to write to it as usual. So here, okay, I renamed this, so this needs to be here as well data length, and here as well. So we're modifying our uniform buffer. But if it's a length, then if number, we assume byte size or length, whatever you want to call it. We can just copy this. It's going to be absolutely the same, except here we don't check the byte length of our data, we just paste byte length. And we're not writing anything to a buffer, so we're going to have to write with our update function. So I'm just going to remove this because it's just abstracting the view. Okay, cool. So next, I'm going to modify update a bit because I do want to write something to our update as well. So let's get to it. Okay, sorry about this. So for our update, we can use this to offset into our buffer, right? So let's see how it will look like. So let's say that we're writing that transform matrix, and transform matrix has 16 elements, right? It's 4 by 4 matrix, and then times 4 is actually 64. Why this 4? Well, because it's a floating, right, point. Floats usually have 4 bytes, and we have 16 elements, therefore 64. So our buffer was previously just 64 bytes, right? But now our buffer, right, this one was 64 bytes. So it's going to say, let's say that we're storing some, maybe 4 matrices, let's say 4. And then we're going to have allocate 64 bytes, 64 bytes here, 64 bytes here, and 64 bytes here for a total of 256, right? So we need to, whenever we write into a buffer, we need to know where our offset is, right? Are we writing to this part? Are we writing to this part, or to this part? So how do we get offset? Well, we can just say here, for example, we can say, what's this argument called? It's called buffer offset. So we're just going to say buffer offset, and by default we can set it to 0. And then we can also set our buffer offset here. And if you don't want to pass here, we're usually just going to pass one transform matrix. But if you want to pass an array of matrices, then you can use this argument here, these arguments here, right? Data offset. So it will be offset of this data, and then you can also say size. So if you pass, for example, here 64 and maybe 128, so that would mean, for example, we have a buffer here, transform, and this is this. Now I'm referring to this data, not this buffer, right? Forget about this. I'm referring to this data. So if we pass, what did I mention? 64, right? So we're starting from here, but we're taking another 64 for the total of 128. Anyway, if you want, you can use this. I'm not, so it's up to you, because I want to keep it simple. Okay, further we actually need to allocate that buffer. Actually, before doing that, let's just modify our pipeline, because as you remember, our transform buffer was allocated here. Let's just not allocate it here. So this is all, we can get rid of this. We're actually going to pass transform buffer as a uniform buffer, and then here it's complaining when we create this vertex bind group, right? It's complaining here, so we can just say transform buffer, or better yet, transforms buffer. I'm actually going to call it transforms. So regarding our pipeline, that's almost it, but we're also going to need one more argument here, and that's instance count, which by default is going to be 1. So I'm just going to slightly break this up a bit for readability. So last argument, instance count, and you usually can see, right, we were already passing instance here is 1, but now it's going to be instance count, and here as well, right? So usually we're going to draw with indices, but you can paste it here. It's even if you're not using it. Okay. Anyway, that's almost it. So the last part, we actually have to make use of all of that, and we can do that in our main. So Here we don't have transform anymore. Here we don't have transform either. We can get rid of unlit pipeline too. We're not going to use it. And here, let's just create transforms buffer. So first of all, buffer. And we had this uniform buffer. Actually, new uniform buffer. So what are the arguments? Device. How many instances? Well, we had 100 instances. Then time. Actually, we can do this, right? We need to know size, and that size, as I mentioned, is 64. But there is a better way of doing it, and we just need to expand our matrix a bit. So we're going to have public static get, and then we can say byte size. And we're just going to return, what did I mention? 16, right? Because our 4x4 matrix, it has 16 elements, and then we can use this byte per element. So going back to our main, we can say here, instead of 64, we can say matrix byte size. And the last one is labeled just for debugging. We're just going to paste here transform buffer. Okay, that's interesting. Okay, here I'm checking if it's a number, but I never mentioned that it can actually be a number. So just do this pipe operator or number or operator. Anyway, I forgot what's the operator called, but let's go a bit further. And actually we can just allocate our transforms. So it's going to be array, but we can just say what type of an array, and it's matrix 4x4. So let's just write to it for let let's go to 100, like I mentioned, and here we can create our this. Actually, we're just going to create our transform matrix. And for now, I'm just going to use translation. Like I mentioned, you can play with the rotation and scale as well. So what we're going to do is do match random. Okay, this is a good suggestion. I already coded this example. What we're doing here is we want to have it in space -5, 5. And same applies for y, -5 to 5 space, if I'm correct. And here I'm actually not going to do -5 to 5, I'm actually going to 5 to 10. So that means that we do times 5 plus 5. Cool. And let's just push to our transforms, our transform matrix. Here we actually need to make use of the transforms buffer. And finally, instance count, right? We mentioned that it's going to be 100, and we can get rid of this. If I save, it should theoretically work, almost, but it doesn't. So it means I have a bug. So let's quickly see what it is. Oh, nice. Small buffer bound size 64. Okay. It means that something, when creating our buffer, I did something wrong. Probably. I'm not sure what. Okay, I fixed some of the issues. First one, I wasn't running properly our server, so that's fixed now. Let's see. And the second here, it's still not being shown in anything, so I have to figure that one as well. So let's see. This seems alright. This Z is 5 to 10. This is probably right as well. But I actually never written to buffer. Okay, my bad. So transforms buffer, we push our, we add our transform matrix, and then we use this offset. So if I say now, refresh, and here it is. Okay, and it seems a bit allocated here. That's probably because our field of view might be too big. I'm not sure. Let's try it small one. Okay, that seems better. And one more thing, I just want to update some of those, right? So we can do that here. And I'm not going to do 100, I'm going to do 10. And then here we can just do this part. Let's copy paste here and then just get rid of this transforms push. If I save and do this, we can see that some of those are updating. So basically that's it for this video. If you liked it, please like, subscribe, and until next time. And actually maybe just to recap a bit on it. So the point is, like if you want to reuse pipeline, you have some material, let's say a tree in a game or some asteroid, something that you need a lot of instances from, you can use this instance rendering. So what do you need to do? So you kind of need to create in shader structure that can hold that instanced array. You use this instance ID, then you allocate in your buffer enough space for your instances, then in your shader, sorry, not in the shader, in your pipeline, you just need to say how many instances are you drawing, and you usually just need to bind that buffer, which we did somewhere over here, exactly, and basically that's it, right? And then you just draw with it. Okay, that's it for this video. Next time we're actually going to do view magics. So until next time.